Hello everybody. So today we're going to be going through our week 3, day 3, defining new operations. And let us begin first with our table of content. So today we're going to be understanding just two main factors. So number one, understanding the rules of new operations and also the bottomers. And with that, we can already solve our NMOS questions. Now, let us understand first the basics of understanding rules of a new operation. So basically, it's just where we assign some special operational rules for some certain symbols. And these symbols are ones that we don't necessarily see very often. As you can see, on the left-hand side here, A star B equals to 3A minus 2B. Where did the 3 and the 2 and the minus come from? So it actually just came from the symbol itself. So basically, all we need to learn how to apply is to learn the art of substitution. So let's say we give these numbers, okay, these letters A and B, okay, a number 2 star 1. And all we need to do is just to substitute the values in. 3A, so 3 times A, 3 times 2, minus 2, 2B, 2 times 1. 3 times 2 is 6, 2 times 1 is 2, then we suddenly get the answer of 4. So that's all we have to do, learn how to substitute the values in. Even on the right-hand side, when we see a very odd box around the number, the same rule applies. So let's say we have it like a box 5. Then we have A times A plus 1. 5 times a number 1 bigger than itself. Then we have 6. Then all we get here is 30. Now, sometimes the rules could be a little bit more complicated, and we have to apply the bottomless rule inside as well. So we need to go and observe brackets before multiplication and division, before addition and subtraction. So there is a certain set of rules that we must learn to apply, okay, when we are solving such questions. And let's say we put in some numbers inside here again. Okay, A star B, 1 star 2. And let's say we place these numbers in, remember about the rules that we need to do first. So number one, just take note, we can just try to substitute the values in first. Then after that, we add with 1 plus 2. But because of your rules of bottomless, remember, we need to do whatever is inside the brackets first. Solving the brackets, then we have your multiplication, 1 times 2, 2. Then your addition and subtraction, 1 plus 2, 3. And just like that, we get the outcome of 5. So remember, always do your brackets first before your multiplication and division, then your addition and subtraction in this order. But of course, the bracket plays the biggest role. So even inside your brackets over here, if let's say there's only multiplication and division, of course, just do it in that order. If there's only addition and subtraction, just do that first. And we move on to our NMOS question already. So for a positive whole number n, the expression n, and there's actually a name for this one. Okay, it is going to be something that many students will eventually learn in secondary school. But for now, we are already applying it over here. N factorial is defined as the follows. N equals to n multiplied by n minus 1 multiplied by n minus 2 all the way to value of 1. Basically, we multiply the number itself by the number 1 smaller than itself all the way to the last digit of 1. Now, we want to find a 3-digit positive whole number, which values over here is equal to the sum of the factorials of each digit. And there are already some quick examples that we can think of that will help us to focus on this important part. 3-digit positive whole number. So if we try to go and think of some numbers that could eventually lead us to a 3-digit possible whole number, positive whole number, let's think about 1 factorial. It gives us just 1 times itself. So what? 2 factorial, 2 times 1. We get 2. 3 factorial, 1 times 2 times 3, 6. If we continue on with a bit of our calculations over here, 4 factorial will give us 24. 5 factorial will give us 120. And let's say we try a 6 factorial. 6 factorial will give us a 720 already. And there is a little bit of a hiccup here. Now, if the outcome over here of the number is going to be 720 and above, one of these factorials will actually require to be a 7 or maybe even a slightly bigger number as we continue to add more and more numbers to it. a 7 factorial actually automatically gives us a 4-digit number already. And any number after that is just going to get larger and larger. So just based on this idea alone, right, we can already see that firstly, 7 factorial would not be part of the answer, and 6 factorial would have been too large. So frankly, we only need to look at the numbers on the left-hand side over here. Now, in order to get the 3-digit positive whole number, we need to at least have your 3 digits. If we see 4 factorial, even if we happen to have 3 sets of your 4 factorial, it will only give us 24 times 3 to give us a 72. So we can already tell very quickly that 5 factorial must be part of the values. So one of these numbers, whether or not is it whether is it A, B, or C, whether is it any of these numbers over here, that is actually your 5, it's not too important as of now. Because we know that definitely one of them must be 5. It can be B, it can be C. But why did I not say A? Because if we look at 5 factorial, 120, we already know that it's going to include 120 plus another 2 more numbers. Even if I place another 2 of these 24s inside, we will notice that it can only go as large as 168. Same thing, your A is already proven to be 1. So here, A, we know it's 1. All we need to do is just to add 1 inside, because 1 factorial is only going to give us 1. So the last part is actually a little bit more of a guess and check already. Now, if we take a look at the numbers here, 120 plus 1 will give us 121. We can try to add a number 2 inside. But if we added, let's say we do a little bit of guess and check at this moment, we add a 2. It give us 1, 2, 3. Then firstly, the 5 is not present. There's a little bit of a problem. So we need to go and try some other numbers. And you will notice that if we even added a 3 factorial, it will give us 1, 2, 7. Which again, 7 cannot be part of it, and it's also missing a 5, so we can't do that as well. But we can actually add this 24. This will give us 145, and where did the 24 come from? It came from 4 factorial. So just based on these options, again, we need to go and understand there is actually a clear way to deduce the value. Where we have a 3-digit number that could only come from 5 factorial, we know that one of these numbers must be a 5. So we know that there is a 5 inside. Now, the second part is where we already know that hundreds place cannot exceed 1. Henceforth, 1 factorial is definitely inside, which has to be the value of A. Now, we only need to go and finish off the last part, which is to have a 5 within our answer. And the only way to do so is to add a 24. 24 happens to be a 4, 1, 4, 5. So our number over here is actually 145. Where just to go and have a quick last bit of a summary over here, for the sum of these numbers, we see that 120 is actually 5 factorial, 1 is actually 1 factorial, then 24 is actually 4 factorial as well. The sum of factorials is also the same as its 3-digit number counterpart. And the answer in this case is 145. So please take note again, there are 3 questions that we need to do for today's NMOS. So always remember to go and complete all 3 questions, send out the answers inside the group chat, and later on, please take note of the solutions that will eventually be sent out inside the group chat. Thank you, everybody.